Okay. All right. I guess we can get started. All right. Welcome, guys, to the 3D printing workshop. I am your host, Yash Karwal, as well as the president of Hyperloop. So today we'll be talking about 3D printing. How many of you guys have a 3D printer at home? None? Ever used any 3D printers before? You've used them? Maybe seen some 3D prints. So I have some over here for our soldering workshop as well. We 3D print the cases for these. You guys have probably seen these before, as well as this one for our first season. Some of my own projects as well have been this right here, this little house for my dog, a little bobblehead dog in there, that I painted. As well as a little polar bear I 3D modeled for Minecraft. So yeah. And then this car that I built a few days ago, which is also the wrong model, but it does work, I guess. So I'll put this over here. You guys want to see it right here. All right, so let's talk about what is 3D printing first. So, all right. So what is 3D printing? So a lot of these printers right here use this filament, this roll of plastic. This type of printing is called FDM, or fusion deposition modeling. Here, this filament right here will basically go into a heater on the end of this nozzle or on the extruder, and it'll take out this melted plastic. And it'll build into layers. We see a lot of these prints right here. You can see a lot of the layering that you can see. How we can see around, or even I think especially on this house over here, you'll see it because this is some cheap plastic, so you can see a lot better on this one as well. So it's pretty easy. It's very affordable. Anyone can basically get their own 3D printer. These two over there cost about $100 to get. This one right here is about 300. But yeah, it's affordable for everybody to use. Some other types of modeling or 3D printing out there is like SLA, which is resin printing. Have you guys heard of the resin printing? No? Okay, so this is liquid of resin that the printer will basically cure using a UV light. And so it'll solidify that layer of resin. As it goes up, it'll build your part upside down basically. And then you cure it afterwards. But it's like a different process of like modeling your print because you don't want to put a hole in there so it doesn't explode. You cure it. There's also another type called ceramic, which is a powder. It's for making like high temperature parts. It's used as a powder too, and it solidifies the powder as well for 3D printing. It's like metal 3D printing as well. It's all sorts of stuff out there. All right, some 3D printing materials. For FDM, you have all of these available to you and even more. So your main type, most affordable, is PLA. It's corn-based. So it's in a way sustainable, but plastic in general is bad for the environment. It will not biodegrade as well, but it's very cheap. This roll here costs about $20 or less. It's very brittle though, so it'll snap. And also the temperatures are very low. So if you put it on the sun, it will basically melt. And then we've had multiple experiences of that before. ABS, if you see any usual plastics out there, let's say this table, or this metal, but any plastic or chair, let's say, right? That's ABS plastic. So it's usually used for injection molding, but sometimes you can also use it for 3D printing. However, there's a lot of fumes associated with it too. So you got to make sure that your printer is in a completely separate room. In general, you want to put it in a separate room for all the fumes, but ABS especially. PETG is like an alternative to ABS for strength. It's also a bit more flexible. TPU is like the most flexible one out there, basically like rubber. And nylon's also another alternative for PETG. And PVA is used for soluble, like for supports. So if you want to melt, so you can use like dual extrusion 3D printers they will have like a separate nozzle for PVA filament. So you can put in the water and it'll like all dissolve away. And there's also composites like carbon fiber, Kevlar, fiberglass, wood, like any metal flakes. So yeah, it's a lot of stuff out there. All right, it's about safety real quick. So make sure that your printer is in a separate room. I suggest completely separate room than where you live. because all the fumes you don't want to inhale, all the microplastics you really don't want in your lungs, especially for certain filament like ABS. All right, make sure your hands are safe. There's a lot of motors, a lot of moving parts, and also the nozzle gets really hot. It can hit like about 300 or so in some printers as well, and that's like 3 times the boiling point of water. So be careful. Yeah, that's build up. Yeah, that can hit about 100 degrees or so Celsius. So boiling point of water, you can cook an egg on the bottom, and like really engrave on it on the top, I guess, if you really wanted to. I've warmed up a Pop-Tart before on this. Don't use plastic plate for the Pop-Tart. It will infuse the plastic into your Pop-Tart. It tastes like trash. Do not try. But aluminum foil though does help. But yeah, so all right. Some more. Let's see. So yeah, make sure you wear a proper tire. You don't want any loose, hair or any loose clothing that could end up next to the printer. It can go into the motor, or your hair can get singed into the nozzle. And again, lungs, very important. They're good for you. Healthy lungs, healthy life. So yeah. All right. So I'm gonna speed run this right now because I want you guys to use these printers as well. So calibration. Calibrating is very crucial. It will be 9% of the problems is going to be calibrating or something to do with calibration, okay? Your bed has to be level so that your nozzle can go around and make your first layer. If that first layer is not good, your entire print will fail miserably. This print right here, it looks relatively okay, but if you can see, this little cuts is coming off on the side, right? If you look on the bottom, I'll share this around, but that bottom layer is actually not the actual bottom layer. You can see the actual infill at the path the thing's taking versus, let's say, if I were to give you this one right here. If you look at this one's bottom layer, very glossy, right? The nice shiny bottom. And then take a look at that one, you can see the actual path of yeah. That was also halfway printed. So the bottom side that you'll talk about is the bottom part is this part right here from the bed. What your first layer will be. Yeah. Okay. So calibrating, most of these entry-level 3D printers have knobs in them. This one right here to glue on the bottom from the back. Those ones over there, they have it right here. Some of them have some larger ones, some of them don't. There's also printers that can automatically level for you. There's a little probe. I don't like them that much because they tend to fail me usually. I can just manually do myself. But that's called probing. And they have these little rods that will basically tell the distance between the nozzle and the bed. Okay. For calibrating, you can use these test prints out there to test, your tolerances for your printer. Let's say your settings are off, your calibration's off. You can test with this. So the classic cube is just a cube that will basically you can use to dimension and see if what you said on your 3D model, right? You want 200 millimeters. Is it 200 millimeters in real life or not? Right? What are your tolerances of your printer? Or what are the measurements that your printer can actually do, right? The flow cube will tell you your flow settings or how much infill or how much material is using. Is it too much? Is it too little? That one, the black plate right there, I feel like it has too little infill or the flow is too little. That's why there's gaps in the actual print. The CaliCat is for overhangs, things right here. So it's printing out overhangs. Let's say in the car that I was building, it's a lot of overhangs on that one as well. The 3D Benchy, that's the boat up there. The boat is one of the most widely used benchmarks for 3D printers, just because it gets most of the job done. You can see overhangs. There are this normal actual arcs versus the side of the boat. There's the layer height and everything else over there. Dang. Be careful with that one. You can even the wheel back if it's too heavy. You just put the wheel back up here. Yeah, just put the wheel back up here. And then the torture toaster is for basically a print in place. You want, I'll say, one print that can actually move. So it's a good tolerance tester. So whether your print's good or not. Okay. All right, some quick troubleshooting stuff. Lesion settings, right? So your first layer, again, most important layer. If this layer is not good, none of your layers are good. Your entire print will fail into spaghetti, as you'll see later. So if you're messy first layer, make sure your nozzle is calibrated or not. Elephant's foot is basically the expansion of the bottom first layer, which is too thick. That's usually because your bed is too close to the nozzle. If it warps or it lifts up, that's again, it's not a distance problem. It could be a bed heating problem or adhesion problem as well. And then material could also cause problems for you. Again, this right here, like the cheap plastic, you can see like lines on it too. It gave me a whole headache with all these problems. Okay. Yeah, so filament issues is all stuff with part of your slicing. So what slicing is basically your settings that you'll be sending onto your printer. Your printer doesn't know how to, actually make your part. You gotta program it yourself. Program it with using a slicer. So you'll see later, I'm gonna show you the entire steps for it. So it'll make sense hopefully over there. But stringing is like this. You have little strings on there. So that is all retraction settings that you'll see later on. Again, you can use all this as reference. This will all be up on the online. So yeah. All right. Print shifting is one of the major concerns. What can happen sometimes is that if your print isn't stuck to your bed properly, if there's some like leaking on your nozzle, it'll create some kind of buildup that will basically knock your print. So see right here, so it works on a belt. I don't know if you can see the belt on the side right here. This belt right here. So as you move this, the metal will move. So something that's stuck onto your print. It stops the print from moving. The motor will keep moving, but your belt will slip. And then that'll basically reset the distance to a different unknown spot. It thinks that your nozzle's over here, let's say. Your nozzle's over there. So that'll happen. That'll cause print shift to happen. Because it thinks it's somewhere else and it's not. Okay. Salmon skin. That's when again it's a bit more extrusion settings that you can change later on. So up there for you guys as reference. All right, slicing. Let's talk about slicing. Okay. So this is basically for, again, programming your printer to print. All right. You'll get a object, let's say in STL or OBJ. So just triangles. And your computer has to, or the printer needs basically layer by layer definitions on how to print. So to basically sketch your print and build it up from the top. That's where slicing comes in. It'll also put all your material settings as well. So infill is how much stuff is in there. If you look at the black bar, on the other side, if you flip it over, I think you have it right there. If you flip it over, that's the infill. If you look in the inside pattern, that's all the infill. On the outside is actually the wall thickness. You see 2 lines of walls as well. Support, I've used that on the car over there. If you look underneath the wing, if you look underneath the main bridge, you'll see a lot of like imperfections. The supports used to be there. If you look on the plate, actually, on my printer, when I actually built it, right here. So the main car was printed, the outline was right here. But the supports is kind of all over there to kind of help build up the car. Yeah. Print speed, travel speed. The print speed is how fast your print's going to be printing. Travels for when you're not printing, how fast this moves to the next point. All right. Temperature, will temper temperature, your bed temperature, your nozzle temperature as well. And you got to make sure your orientation for your print is right. You don't want to print, let's say, if we're to print this house, right? I'm gonna. Okay. This house, how would you imagine to print this? Because this printer will print from top to bottom. Would you print it like this? Would you print it like this? Like this? You want the optimal setting where you'll have the least amount of supports needed, where it's the most stable and won't knock over. Printing like this is like the worst possible way, right? You have a small point of contact right here on the bed. It can just tip over, entire print will fail miserably. You also need a lot of support. So the way I printed this was like this, just because the filament will support itself as you build up, kind of like this, kind of go over. And it's the most stable. versus like this, where you need a lot of support inside of it. Okay. And okay. Okay. So again, I talked about flow before and how the black one over there needs more flow or needs more material to be pushed into by the extruder motor. Right? Retraction, when you move from one point to another point, you don't want it to be like oozing out of it. So you kind of retract the filament back and suck it back so it doesn't like keep flowing through. And combing is, I think, again, a lot of these prints you can see like basically the printer will go over past prints and it'll create like a line. Cooling is for the printer fan to cool off the printer. And bridging is like this basically. See how far you can go without any supports. And then when prints fail, or if you're say your first layer is terrible, right? So it fails to print, you'll get a mess like this. And it's the most painful thing you'll have to work with, because not only is this already a pain, so looking at it, your nozzle's entirely messed up. It's all full of like plastic everywhere you go, and you just a mess. Try not to do this. Just so always watch the first layer. That's like the key. Watch the first layer. Make sure your first layer is calibrated. If it's not, then you let it run for a day, 2 day, or the car over there's 4-day print right there. If it messed up any point, never checked up on it, because that first layer was missing, it's be a 4-day mess. 2 rolls of filament gone, which is like $40 to like $80 down the drain. Okay. All right, some accessories they have, and also, a lot of these printers right here are hobby printers that I have. So these printers right here, basically you can upgrade yourself. You can build it yourself, you can change things yourself. There's stuff like CR Touch, which is like Realities, which is like a brand of printers. They have their own automatic bed leveling stuff. There's Octoprint, which is the open source for monitoring your own print. You got Raspberry Pi, hook it up to your printer. You can send it files to the cloud and make it print to the cloud. Nothing can be there. You can put a camera on there. It's like really cool stuff. There's a lot of other upgrades you can do to your printer. Make it fully autonomous or make it like fully customizable to you. Right? Okay. And then there are some more links for any other things you guys want to need for reference. Okay. So let's talk about how do we get from, let's say, a CAD model to an actual print, right? So have you guys 3D modeled before? Any 3D modeling experience? 3D model? Have you 3D printed yet or no? Let's see what happens. So okay. So let's open up my 3D modeling software, okay? There's multiple ways. I'll show you guys also a website you guys can use for finding parts online. It's called Thingiverse, so THIN Thingiverse right there. If you go to this site right here, you can see a lot of open source 3D models out there you guys can do. So let's say I don't know what you guys want to find. Halloween decorations? Okay. Let's go to Halloween decorations. Cool. See what they have. So all these are 3D, most of them are 3D printable. You can get offline, online, and then download it, then go through the steps I'll show you soon, and 3D print yourself at home. It's all free to use, all open source. It's different things out there. It's a pretty cool site. All right, let's say you have a CAD model instead. Right? Let's say I'm here. I want to build my car again. So I'll bring the car today. Okay. This is the chassis. All right, so there's the chassis that you guys will see over there. All right. Let's say this time around, I want the entire thing. I want to also print the front and back as well. So there we have the entire model. Right? Let me move this to you. Okay. So we're gonna go here, the file, export, and make it into either OBJ or STL. When you go online to find any 3D models you want to print, OBJ and STL are your best friends. Also 3MF, but that's like less used right now. So if I make it to say into an STL, STL, export this one. All right. And then when it's done, I already have a lot of other files, so I can just go to my slice it. So I have two slicers here. One is called Cura. This one right here is open source. It's free for anyone to use. If you have your own 3D printer or want to buy your own 3D printer, this one, say your best bet, has a lot of functions out there. You can set it up pretty easily. If you need help, let me know. I can help get set up this one. Has a lot of materials, has a lot of printers themselves. If you build your own custom printer as well, I can build it off of here too. I also use a paid one called Simplify. This one here is very cool. This one has some other stuff that Cura doesn't have. Like as you build up, you can say, let's say I want a more dense bottom base, a thinner or less dense topper base. You can do that. Different infills, different size. Right? So let's do Cura because Cura is more open source. Everyone can use that one. All right. So let me switch this to so I can actually use this on my. Let's see. Okay. Okay. So here is Cura. So when you first make your Cura, right? Let's talk about machine settings first. Let's choose your printer. Each printer has its own properties. All right. This one has a bigger build plate, sort of smaller. This one has, I think, a little better servo motors as well, and different like accelerations as well. So let's say I want to do mine on. You can use this one for now. So I'll select that one here. You can also add printers. You'll see all these printers out there that you can also buy. So list. Question or no? Okay. Okay. So then over here, let's go to manage right here. The machine settings. You can see all the different specifications, right? You have your XYZ. We have your G code. So G code is basically the code that it will run. I'll show you later on how this code looks and how it will read it. Right? It's like that. So this code right here is the starting code, and then your ending code as well. And then your extruder settings. So what kind of nozzle do you have? So the nozzle diameter is this little tip, this bottom right here. That will heat up where all the filament will come through. So a thicker nozzle, I'll say, first like the default thickness for a nozzle is 0.4. 0.4 will give you basically your best for everything kind of nozzle. Most printers ship with it. But you want a thicker nozzle or a bigger size, it's like 1 millimeter or so. The thicker the size, the less resolution or less quality you're gonna have in your prints, but the stronger your print's gonna be, and the faster you'll print as well. All right. The smaller it is, to like 0.1 millimeters, I think. The smaller it is, the more details you'll see on the outside, but also means the more layers you're gonna need, the more walls, the more time it'll take. So you gotta figure out what's the best quality for time. That's gonna be your key, optimizing your quality for time or strength for time. Okay. So my nozzle here is 0.4. So yeah. And then material diameter also matters. Make sure when you guys buy your material, it's the same size as what your material, what this can actually support. Some printers out there use 2.85 millimeter thickness for because of this filament reel. Most of them do use 1.75. This is the standard. So yeah. Okay. All right. Let's say we want to import. Let's first change our material. So Orbium is this filament I have right here, right now. This is from the company I used to work for. So, but let's say you want to go back to love the PLA for my eSIM. But yeah, we're gonna use Orbium for this one, which has a higher temperature than PLA. So PLA, its melting temperature is about 190 to 225 or so. And then its bed temperature is like around 55 to 75. Orbium here uses 245 for its nozzle and 65 for its bed. So you guys kind of know what materials use what kind of settings. All right, let's import our. So I have a bunch of like STL files here, and let's say I want. Let's want a key. So this key is from our last 3D printing workshop, which is a escape room. So look at this key right here. And this Hyperloop, yeah. So this actually unlocked into one of the rooms that we had. But do you guys think this orientation right here is good for 3D printing? No? Why not? You gonna tip over? Yeah, so it's a very thin part, right? So, and it's because this bed moves. Some of these prints, their beds don't move, but some of the bed moves as well. It's gonna knock it over. So we're gonna align this real quick to say right here, rotate this right here. I'll let you click on the face you want to align it to, and then you'll put on four. All right. Let's go over here. You can go through some settings here. A lot of these settings have a lot of the advanced settings on there. You don't have to really, you can like play around with them if you have your own printer as well. But the ones I usually go for are, first of all, quality. You know, your layer height, or how thick is each layer, right? If you look at the car, right, you can see the layers on those ones. You can see the layer height on this one as well. Each layer is very usable. And this one's too. On these ones right here, they're put on a nicer printer. I'm gonna pass these around as well. Here, the layer height is very small. It's almost flush. I'll pass the other one around as well. This one. Yeah. So that one is built on a nicer printer that costs about 1,000 or so, versus let's say the ones that I have car right there, or the other one, 300 or so, right? So you're seeing a completely, change in the price, right? So that's the layer height. So I think that one right there is like 0.15 or so. And then, so the thinner the layer, the more layers you're gonna need, the more time it'll take. The thicker the layer, the less time you'll need, but also the less resolution you're gonna have. Like the less quality you'll have on the print. You want to also make sure is that this is, I forgot what I was gonna say. Sorry. All right. Also, the thing you want to look at is your first layer height. It's like just overall for that first layer to make sure it sticks. Mine's at a lower height than everything else. Yeah. And usually your layer height, your general layer height up there, you'd want it to be, the maximum it should be is half the nozzle diameter. So for my nozzle is 0.4. So 0.2 is the max I'll take it. Right? Any higher, there's a problem with the layers adhering to itself, and you'll have some stringing, and your thing will pull apart and miss it pretty easily. And then I think look at is the walls or wall thickness, or how many walls do you want, right? So here I have about 5 walls on the setting. So that's like 5 outlines before, for each layer. You can go 2 walls. 2 walls will basically be only 2 outlines, which will mean less strength on the outside part versus, let's say, 5 walls. Walls use more material as well. So you gotta, again, a lot of balance. 3D printing is all about balancing quality and time and material and money. Yeah. There's a lot of stuff as well. Top and bottom layers are how many solid layers do you want to basically finish off the part? How many base layers do you want? How many top layers to finish? If you have 0 top layers, what will happen is you'll see all the filament. You'll see the infill pattern more. And I'll show you right in a bit like how it looks like. But typically you'd want like 4 top layers, or instead of 6 and 6. But 6 and 6 is a bit too much. 4 and usually is a good amount. And the infill is how much stuff you have. So most 3D print stuff is about 15 to 25% is your usual infill density, or how much material is inside. Anything higher, again, you lose in cost, but you'll gain in strength. really, it could be really dense. I think 50-60% infill is being pretty, it's about a pound or so. Okay. And the material settings, so you can see your temperature settings over here. Speed is how fast, prints. Most of the time, your print speed is going to be 40, 50, maybe 60. That's kind of pushing it, millimeters per second. Some printers out there, like it's called an Acre Make. It can hit 500. It's really fast, but it's really expensive. But so it's probably like industry kind of printer. And then we'll go straight to support. Support material, you'd want to have a bit less than your actual infill material. So support material is the same plastic as you do for your main material. You'd want this one to be like 10% infill, so you can easily take it off once you're done. If you have, let's say, a water soluble one, PVA, your dual extrusion, then this is fine for you. On Cura, it's really cool is they have something called tree supports, which are basically create like little branches instead of the normal support structure, which will optimize on your material use as well. And then how about build plate adhesion, skirts and brims and wraps. These three, very important, I would say. Almost every print should have at least one of these. Most of the time, you'd have a skirt. A skirt is just the outline of the part. So if you want to print, let's say, I want to print this cylinder, right? It has a very nice large surface area, which means it'll stick very well to the plate itself, right? Then the skirt is what you'll be using. It'll make an outline around the actual part. That will help you calibrate the printer before it prints your actual piece. That way you don't waste any material and like your stringing that happens later on or something, right? It'll also help us make sure that your material is ready in your nozzle itself. Because sometimes what happens is your nozzle doesn't have no material inside of it yet. A brim is like a skirt, but it's attached to your piece. It'll look like a brim, like a hat. And this is good for stuff like more complicated, say, or smaller stuff like this. I want to print this like this, maybe, right? Very small surface area. Then I'll use a brim to kind of largen that surface area up so it sticks to the plate. Or if you have a really large part that has a tendency to warp, because what happens with warping is that your plastics want to shrink when they cool, right? So when they want to shrink, it will kind of come up. So for the car over there, I put a very large brim. Can't really see it, but compared to the main part, the brim is about like this part. You can see a part of it right here on the support. Let's take it out. And then, okay. This right here is a part of a brim for the support materials. It's right here. There's like a little flat first layer to keep the support onto the plate so it doesn't fall over or something, or cause problems with that. A raft is if your bed is absolutely terrible, you don't have a solid first layer, you can never put one out. You take some material from your plastic, you make your own bed underneath the part, and then put your part on top of that one. Because the best adhesion happens to the same material. So that's in case you just cannot get your part to work. So that will take a lot more filament. Or okay. Everything else looks experimental and everything like that. All right. So let's say all of these are good, right? All these things are good. I want to get this ready to slice. I want to put apart. The first slice, it'll give me an estimated time of 11 minutes, right? I can calculate how much, like by putting into the material profile, and put how much it costs. They're gonna give me $7, same thing. So, okay, I can preview this, and it'll show me exactly how it's gonna look. So this right here has a skirt. So you can see that skirt on the outside, yeah? And you can see how it's gonna be building each layer. There's 10 layers total, and it's gonna stack up like this. So this is your first layer, and you can see as it goes, it'll print. So your first will be the inside first, or your skirt first, and then inside, it'll go out, I'll print the outline, and then infill. That's your first bottom solid layer, right? And I'm gonna go up another layer, up another layer. I think it's all solid layers for this one because there's about 6. All right. Then you can export this to an SD card, put it into a printer, you can print it. So let's see you can print this right now. Do you want to print a key? Or do you want to print something else? I have a lot of other models as well. You want to print the key or something else? It's more interaction with people. Huh? I know. People. Want a benchy? Okay, let's do a benchy. I don't think I have a benchy myself, so I gotta actually find it online. So let's go find a benchy. Look at all those benchy. All right. It's a lot of benchies, a little different ones. So let's pretend that this is the right one. All right. So here on Themeworks, you can go down to files, and you see it's .stl. That's good. That's good for us. So we'll download this one. And then there we go. Let's open this new Cura. And so actually, I'll just open up on my simplify instead. So it's a little different slicer, but it's again same stuff, same concept, and just different UI, right? So here I'm going to choose my printer as my printer over there. Choose my material Orbium. Make sure my nozzle is good. Make sure all these settings are. I just go glance over them. If you have your own printer, you'll see or you'll know these by heart, kind of, because you see it so often, right? And make sure my layers. So again, my layer height is what I want, 0.15. 4 top, 4 bottom solid layers. I'll show you how they probably look like. And these are outline perimeter, just walls. So how many rounds does it go first? And then we're gonna go to additions. This right here is a brim. I'm going to skirt by putting some offset. So like I said, a skirt and a brim are the same thing. A brim is just a skirt, but there's no offset from the part. So I want to put offset into the skirt. And then it's outline 5. My infill, I'll put as 20% because I don't want to really waste too much material on this one. I should put a 15. And then we can change the pattern or what the infill looks like. So I'll show you a little example of each different types. Go support. We don't need supports for this one, but my support, this is my support settings. I do want to use them. My temperature, make sure my temperature is good for my material, right? 245 with the nozzle, 65 for the bed for my Orbium right here. For PLA is different. You gotta know it. I'll also just tell you. A lot of these will just tell you on there what their settings are. So let's see. Yep, 205, 225 on there. So then cooling, speeds. Yeah, and then I have some scripts as well. Okay, so let's delete everything. And let's go to benchy. There is benchy. Okay. And then this is our benchy. So here you see, let's go to the very first layer. The first layer has some lettering on there too. So we'll go. And so you can see it goes up. So this infill here is called gyroid. So you can see kind of goes up like that. And I'll build up on top of that. There's also, most people use say honeycomb. If you want like a strong part that goes fast, that's like pretty decent in the speed wise and good for cost and everything, you use fast honeycomb and it'll get the job done most of the time. See this hexagon honeycomb, right? There's also never use wiggle. Wiggle is kind of, as you'll see, not very stable because it's just wiggling. So I want all sides of the print to be strong. So I don't like to use wiggle. I don't want anyone to use wiggle. I guess could if you want to. I'm looking at the part. Okay, so I'm gonna put it back to I'll put a fast honeycomb over there. And then let's say if I want to put 0 top layers, okay? You'll see right here. You can see the infill on the top because there's nothing to cover it. And if you have, let's say, 1 layer, you see all these gaps, right? So having only 1 top layer, this top layer will not look good because of these gaps right here. Don't only stick properly. You use 4, so the first 3 can kind of take the hit. So the 4th one looks kind of nice and clean. Okay. So I'm gonna put like a 4 here. And then let's say if I chose this to be, say, 80% infill, how do you think it'll look like? 80% infill. How do you think it'll look like in the inside?
Dense.
Dense? How dense?
Very.
Very dense? All right. So even it tells you like, oh, hey, don't do that, but I'm gonna do it anyways. Right? All right, first of all, look at the time, okay? The time over there, it says 7 hours to print, and it takes about 42 grams of filament, about 0.11 pounds of filament, right? And it is dense. So that's gonna be a pretty heavy for its size versus the usual. If we go to here, I want to make 13% control. Only 4 hours. And it only takes 32 grams and the thing of 70 or 80, I forget. But cuts down on time, down on cost, because I don't really need it that strong. You only use over 50% if you really need something like really, really strong. Right? Okay. So after this is done, you can prepare it for the build file. I'll put in my downloads folder for now, just so I can show you guys how the code looks like. So they'll say export okay. So if you want to see what the machine sees, open this one up. This is what the machine sees. The machine's gonna read this. Whole thing is all commented right now. This is the actual code that your machine would read. Is it hard to see? Kind of hard to see. Turn the lights off a little bit. Or not. Turn the lights off? I don't know. That's one right here. Okay. Just turn them on like with the front lights off. Yeah. There we go. Look at how amazing this code is. Okay. So I want you guys to look at this really quick. This is just this boat, okay? Which has 400 layers. Has code that can go that spans about, oh my god, let's see, almost there. All right, let's say that 277,000 lines of code. Can you guys code that in a few seconds, like it just did right now? It has all the settings, remember, all the settings, everything like that, all stored into this nice piece of code. And if you modify this, you will modify the actual part. So if let's say I chose to on like the first on the top list right here. So this right here, this code right here is telling you the x, so x coordinate, the y coordinate, and how much extrusion you should do. So okay, there you go. Make it bigger. Right? X, y, and how much extrusion you want it. So let's say I move this nice y coordinate over there. Instead of being wherever it is to the absolute maximum of my bed, 300 millimeters. So I'll press 300. I'll put the x coordinate as well at 300. Oh no, at 0. Okay, so that's going to be on my printer. 0 is here. 0 on the x-axis is right here. And the y is, I think, it should be back here. So it should be right here. It's going to be, if I remember this correctly. But yeah, so it should be right here on this corner, on the very edge of right here. Okay, so let's say we save this right here. Save as modded. Right? Let's open this one up. Let's open up the modded file. Look at that. Right there on that, where I've told you guys where it would be. So you can easily modify, or you can code your own if you want to code your own slicing settings, I guess. So you don't have to do it though, because it's not going to make your part any better. But in case you want to play around with it, you can do that. All right. So I don't want this one. I want the other one. There we go. Okay. So this is G code. And now we're going to do is turn this printer on. Sorry. Okay. Let's get the SD card from here. And I'm gonna put it into this one. Okay. Right here. All right. I have the file ready. Can I print it right now? Huh? Not yet. Both things I can print right now, or can I not print right now? No? Yes? No? Dang, why not? It can heat itself up if you do press print.
Oh,
So preheating is fine. Why can't I print right now? Okay. I haven't calibrated the bed yet. The bed needs to be calibrated first. And right now, my tape, because I use tape before I don't print the actual glass underneath it. I use tape because I don't want to damage the actual glass bed. So if you see, there's a little like problems with the tape right now because the previous print of the car is trying to take it off. But yeah, I want to first calibrate this print, this bed, and make sure it's level for what I want to do. So I'm gonna print this in the center of the table, this bed right here, which is relatively, it's okay to print on, luckily. So I'm gonna go and first of all, what we're gonna do is heat up the bed and the nozzle. So I'm gonna turn the heater, change this to my printing temperature, right? $245 on this one, and then 65 on the bed. When you got, I want you guys to also do it on your turn later on, or these two, take it in groups. On those will be PLA, so a little different on the setting wise. But bring that, like for the nozzle and heat up, because material will expand up, and that will change the 1 millimeter distance that you need to calibrate the bed. Right. Now let's go to group right now. 8 and 8. Groups 8. We're gonna go to these two things. To the side. 8 people on each side. Now go all in together. And then get up print one today, maybe. So with these prints right here, a little different than mine over there. The on switch is on the side. So someone turn it on. Someone turn it on. Pick it up. Move around. Yeah. Okay. So, our first question is you guys filament inside already? Or when you guys first get your printer, right? There will not be any filament in the actual process. So if you look at this spool here, right? When you guys store filament away, make sure you never let it go. Never let the loose end go. And put it through something, like say the spool right here on the side, to make sure it never tangles with the rest of the filament. Okay? So on that one, it's actually good. So I think that's good for now. We'll feed it in a bit. This one right here. Luckily, all right. let's press clear the bed. The key is not on bed. So on your guys right here, click on button first. Yeah. Okay. You click on button. So on this one, scroll down to and then I'll do something small. Okay, need that killing. Yeah. Prepare. Prepare. Yeah, got it. Pull down. PLA. If you guys do want to do custom temperatures, I can control. Or okay. So I think it's heating up right now. So that. Let's see. Power there, right? Okay. While it's in that, I'm gonna go to my printer real quick. So my printer's ready to print. The on the bed, keep breaker on the nozzle. There we go. Okay. So I'm gonna do is I'm gonna move this all the way from the home axis over. So what homing does, I'll set it 0 points. It's origin. So right now, when you first turn it on, it doesn't know where it is. You can show it somewhere in the space, doesn't know if it's at 0, if it's at 500, you don't know. So has these little switches. If you look on closely, it'll switch. We say right over here. That's the X switch. The Z switch is 3 things back here. Here, look here. The X switch is over here. The look back here. Down here. And the Y switch is back here. So after 0 points. Right? If you guys want, you guys can also, okay, no, I'm going to be done for now. Okay. This is ready. I want to look at its current, the height of the nozzle for the bed. If you look at it, relatively safe. You can come closer and look at it. Thank that camera. Hold on. The camera up. All right. Press back, close settings, and turn off the motor. You have to show this around. Yeah, I think this is broken. It's okay. Exactly. That's okay. That has to last. Yeah. You move around and see. See many streaks on the actual tape. So that means the bed's kind of really close. So my bed is a little higher side. So I'm gonna lower this a little bit, 54 now. That you know what to do. Okay. All right. First, I want you to put the best forward with this one right here. Come on. Okay. So go press the button. So go to control. Go down the coordinate. And load. Alright, so okay. So first put it all the way to here. So take your filament out of the roll this right here. Here's through over here. Don't do it. Click on. So take the filament and use your outlets. Take it out first. Oh, this is okay. This is old filament. Agree. In test PLA for how old it is, depending on how fast it snaps. So this right now is fine because it's been a little while. Not too brittle yet. Hasn't absorbed much water yet. And you kind of freeze through here. Feed through here until it hits the gear. Okay. So that's it. Okay. And that's it. That's the button. Go down to there. Go down, go down, go down, go down. Okay, filament, yeah. Then back. Alright, let me look a little bit from the, okay, and I'm first of all, remote. Alright, so we're going to finish unloading. Once it's load, I'm gonna do it, okay? Ready? Nice. Someone go onto the screen. Someone wants to go in. Someone see. He's gonna come. Oh, that's one. No. Okay. Press the button. Press it. Yeah. Scroll down to there. 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 Yeah. Go down to. Scroll down. Is it ready? Yeah. And push it in. Change the building and the building push it in. Push it in. Can we still have it? No, is this the initial one or something? Oh, okay. All right, and then we're gonna unload. So say for instance, no deep. So all these transport loading things, they use the force potential from back here to push them through. There's also direct drive loaders, which are printers that have the actually this piece right here on top of it. Those printers can print flexible filament, they can print other types of filament as well. These are the here for filaments. All right, so somebody has been used push this in initially and you press the button. Is that enough? And also, yeah, so press it and push it in, okay? And then hit it. Yeah, got it? You got it? Nice. Okay, good. And thanks for it. You just see filament coming up. So you see any filament coming out now? No? It's yeah. I don't think that's true. I want to see a nice amount. And then the peak and stuff. Yeah. So keep on encouraging more until you start to I don't see anything coming out, so so until you see a stream of filament coming out, you really encourage. Somebody come up. Yeah. So just keep doing it until you see start seeing filament come back. Keep in. So this is something. See that filament over there? There we go. Alright. So if you see a little bit of difference between this filament and that filament, when you see it coming out of this one, you see a lot of cooling of like liquid. So plastic, right? Versus that one was kind of nice thing. That is a more expensive filament than this one. Never get Amazon basic filament, guys. It's not work. So remember, let's unload the filament on this one. Let's put a better filament on. So press continue. Press button again. Go down to prepare. Go down to filament. Filament. And change the filament. Yeah. So instead, what you have to do, use the other roll. There it is. Better filament. Don't feel like this one. So I've had personal experience with Amazon Basics because the previous president gave me this amazing role. The house was built from some amazing Amazon Basics people. And then not only did it break my printer for a good couple of months, the actual like the scratches you see on the house itself is because of the plastic. Because it shouldn't scratch it. It's because I think the way to do it, the center of it is full white, something I don't know. It's weird. Bad. Don't do it. Somebody else grab this spool here. Put it no. Sure. Let's pass this. This is a waste of time. What? Yeah. Was it 1.75? Huh? 1.75? Yeah. So never lose grip of the actual end. You don't want to tangle, right? Oh. If you let go of the end, right, and it tangles with the filament, what will happen is as you keep this, you go 5 big print, right? At some point, it's going to not go, and you won't be able to fill it through. You won't feel the print. So always be careful with the filament through itself. Don't let it unravel. So you turn up. You shouldn't. There we go. That would hurt a lot more than. Okay. Okay. No, no. Great filament.
I'm gonna do it at home, and if it fails, I'm suing you.
Huh?
I'm suing you.
It's gonna break your printer. This thing was the static, like, each part of its life of that filament or thing. Okay, so on here, let's do some calibration. Oh,
Yeah.
huh?
If you have a transmitted filament that halfway through, what do you do in that case?
All right, perfect. You do what I did right here. It's black, first I put white.
Yeah.
Because I filtered one out.
Forever.
Oh, there's the electrics.
It was a choice. Well, it looks cool though.
It actually looks nice.
Yeah, but it's all wasted time. But a lot of these, this is a $100 printer right here, right? It has a filament sensor right here that will tell you will stop the printer from running once the filament has got enough filament left to push it through. That's where you take the filament out. With all these loaded printers right here, you will have about the length from bottom here to over here, extra wasted filament, because the pressure comes from back here. All right. Right, so yeah, keep doing it until you start seeing them out. Okay. On that, let's talk about calibration. Is that right over there ready? Yeah. All right, cool. Almost there, almost there. All right. So calibration. So there's a few methods for calibrating these printers manually. So if you have like printers like this price print over here, it's all manual, all with knobs, a little bit hard sometimes. And you have to do is basically find the sweet spot. If we go to that, the nozzle being about 1 millimeter apart. Right, it's very small. You get the survey.
You don't see the one. It's literally good.
That's pretty right. That's okay. Okay. You see, it's not pulling up another one. This thing is called beads, isn't it? So it's good. All right.
This is the
Beads.
yeah. Yeah.
Okay.
You know the change.
Beaded.
Yeah.
What are beads? Oh, yeah. Got it. Okay. So when you start off calibrating the bed, when you're at level, use a field paper. And you come like me, use your eyeball. So that's how I calibrating. So when you first get your bed, ready to go, and you hold everything to fix the 0 position, all right? And what we'll do is we'll first put the first corner and then the left frontmost corner, right? About here. I turn off my motors once I get to the when I home it, just so I can move it around and see my own. So get a piece of paper, get it through here, and then basically try to see how much can I move the paper. Right? So this right here is actually pretty thick. And then you can come over here and like feel the paper. Yeah, move it around and see. Feel the friction of the paper. Right? It's not too tight, it's not too loose. It's like nice enough. You can also feel it. Anyone else? Because you gotta do it yourself over there as well. So good to know when you calibrate. Because you want basically about this much pressure on all 4 sides. And then also the center. All right. And then, all right.
Yeah.
Yeah.
So we probably do that before warming up the.
You do when it's hot. Because the materials expand. The nozzle expand by a little bit. The bed will expand by a little bit. So you want basically at the optimal printing conditions, you want to calibrate with that condition. Yeah. So calibrating, if you're at home, you shouldn't need that often. You should go to print a few times before you cover it again. If you're at school and everyone else is here as well, every single day, every single time, always make sure, right? But usually you can get good enough with this first, and the rest of them is printing. When you print the first script, it's gonna fine tune everything, right? So then let's say so the second side is about here. Put this one here. This one right here, I can't even put the paper under the nozzle, right? So I'm gonna lower this right here, this knob. I'm gonna lower this by this much. So lowering, this means you move this way. So kind of like sit on a screw basically, but I'm not. Yeah. So lower it enough, you can push it through, and that's too loose. So if you like, but you're still not trying to feel it. It's good to know all the. That's like nothing. Yeah. Right. There's no friction at all. And then I'll raise it by a little bit, so unscrew the nut right there, and moving it around until you get like a nice, like soft, not too hard. Hit this much. It's like it's a lot more softer than this one right here, because you don't want the bed to be actually in the nozzle to engrave in the bed. You want it just above it, so you can fine tune it after when it prints. So it's a little on the lighter side, but it's still like you can still hear it in the space. And I do the same thing for the back. And then so like right here, there's a lot more tighter on this one. So a little bit small increments was one of the possibilities here. Yeah. And then so the reason why this right here is pretty badly cluttered right now, or relatively bad, is because I moved it from my house to here, you know. So that's gonna cause some, you know, differences in the actual build plate itself. So yeah. And after you get the center, or the side right here, you wanna go to the center. Okay. Yeah, center this up a little bit. And so we're gonna print back of Benchy itself. So it's still like, it's still a little bit on the higher side. So I'm a bit more on the four corners, small increments, just to lower the overall build plate a little down. Okay. There we go. So this is like the amount right here is like basically perfect. You're gonna feel it right here. Want to feel it? Really, I'd say it's like basically almost perfect. It's not too loose, not too tight. But yeah. You want to push down on it though, because the bed will also move down. It's kind of like I also use like two hands to like move it around like that, just to feel it. All right. Anyone else? Then I'm gonna start printing the pin. Okay. All right. After you calibrate the paper, you can print. So find your print. And that's the Benchy. All right. This is already preheated as well. So we'll get ready to print it right now. So print. So let's see. There you go. So first foams itself. And I'll create a first, like it's called a little like kind of just timing it's called. I'll make a little span in the front just to get the filament ready to go. And then after just a little bit of that, we'll go to the center. We'll see what happens is here. And we'll do the very first layer. So let's see. Let me also come closer here. Let's talk about the layer itself. All right. So you see how the top, this right here, this side right here, is a lot nicer and flatter. This back right here is a lot thinner, like a thinner ribbon. I should probably do that. Okay. Want to hold it? Bro, okay. It's not too long. Come over here. And don't also watch the people. Yeah, all right. But okay. Also turn the light. I'm gonna turn the light on. Thank you. All right. So you look right here in the back, it's a little gap between the layers right here. Right, this gap right here. So since the layers aren't meshing together, but the better is to look. So I'm gonna raise the back right here a little bit, and the front also a little bit right here, just to get those layers to kind of mesh well together. So, and look at that, and so look at there in the back. It's a lot nicer now. I think those two layers kind of mesh in the back. Now turn on the same thing. I was very close to calibration, but not perfect. Yeah, but it's like not a much more solid layer as well. See, it's nicer and flatter as well, versus the initial one. So you'll see. Oh my, fine. So we're at this right here. So the skirt is again one of the most important parts, just because you can see how well your printer is powdered or not. So now it's gonna go and do another wall. And let's see. Let's see, sticky. Yeah. And it'll come closer. Jump over the cable. I don't know. I'm just gonna be careful with the cable. Are you gonna bring like the camera up on top? Like you get this camera. Oh, the camera's not working. That's great.
It's not working?
It's not working either. Like, it's okay. All right. Let's do. You need the foot.
What? Like this. Oh shit.
There you go.
Hmm?
There we go. That's nicer.
I'm so smart.
You
You can keep that up, right?
I'm gonna stop there real quick so I can showcase the. You want to like put on top?
You want?
I'm like,
No, hold on.
it's like, all right. Anyways, so you see it's nice and solid, that wall, most of it. Yeah, lots of printing. We can talk about.
There you go.
Yes.
So you can print the largely high tolerances and plastic shrinks. Is there a way to enlarge it in the sizing software? Or
Yeah,
the
you can
actual-
make it larger and smaller as well. So if I don't secure my screen. Also, don't put the camera there. The bed's gonna move and knock it down. All right. So let's secure this again. So in the slicing right here, go up a little bit. Okay. So if I look like this, you'll see these transforms that you can do. Changing the position, sizing, the rotation. If you want to make it bigger or smaller, make it extra large.
Yeah,
You can also just do non-uniform scaling as well.
you push it.
I can take it up and up. All right, but yeah.
Cool.
So it has all that fun stuff.
Looks good.
But usually you want to fix it all in your model. If you do model. Oh my god.
Wait, you want to kind of like come up here?
That's good. No, it's okay. We get good. Okay. So I'm using the infill. There's a lot of info right now. And see, it's not connecting very well because there's a lot of curves. But as it goes to the next layer, it's gonna go over a different pathway. So if we go back. Here, actually, and then. Back here. So. Okay. So where we have play right, we're playing here. You see that right there? And then we do the fan turn on, just say like the fan with 255 on there. It's a second layer, because that's how mine set up. Anyways, yeah, so it keeps going. Let's do some calibration of your printers. So it's going a lot faster on second layer. The first layer is really slow to make sure it sticks. And second layer can go a lot much faster. Let's see. And see all that, yeah. So I think it'll take 4 hours to print, so you don't have enough time. But whatever we can print, we'll see. All right. We just said it like No. Well, yes, but no. I can hit it 500%, but I don't want to do that. It's gonna cause a clog in the nozzle actually. You go too fast, because then the filament's not hot enough. It's going too fast. So I'm gonna clog up the nozzle, cause more things. So, and also it'll split the belts. Okay, so where's the other paper? There. It's okay. You got ahead. Okay. Calibrate your beds, guys. Calibrate your beds. And accumulate.
Sorry.
Choose a printer. This one, that one, I remember. Okay. What you missed? Someone could talk.
It's okay, I think I know the beginning.
All right.
Things.
So, someone want to calibrate the printer? No. Not you, Nathan.
No.
You know what? Or actually, you don't want to. Okay. Okay. The knobs on this one are a lot smaller. They're down here. Two in here. Two back there. A little hard to reach.
That's right.
Okay. And then let's go here. Okay, we're gonna do this first. Control. Motion. Not motion. Oh. Right, let's go to there. Alright.
Wait, is it auto, does that mean it's like auto looking?
Auto home is just move it to the 0 position. So you're in the automatic. Okay, so let's right here. Press the button. I'm not gonna do it for you. Alright. Go to prepare. Go to. I think this is prepare. Go all the way down. All the way down. All the way down. All the way down. Alright, see what's on. Yeah. I first specifically the first first. So I'm going to prepare. So now you can move it all around, right? This is maybe a pain. Okay. So when you guys look down and tell me if that nozzle is going to hit the better. Why is it hitting the better? No? Too high or too low? Kind of high? Very, very, yes. Okay, so let's talk about the first corner. First corner, knee high. Can you use a paper? Wow, that's very, very high. So, first knob, unscrew the nut, move it up. You also move this up. But with this one, as well as the other ones, because if you have it like a square, if you move one side, yeah. Okay, this is triangle for now, okay? If you move one side up, it'll move the other two down. So, how's that one going? There. That's the first bottom layer. See how the first little bit of the patching, you only have more than one bottom layer? On top layer. And also this is kind of dangerous. I'm gonna just go to the side so that. Alright, so. Alright, how are you guys doing over there? You wanna put one large right? But with all four personalities. Oh, then we can have it all.
Oh.
Yeah,
No, it's still good.
that it happens.
I think Python.
But everything's still pretty fine. So.
I countermine all of this. And so, it's like,
You wanna?
Okay, now you can loosen it a little bit.
alright, so,
Me?
A little bit more.
Oh, it depends.
Okay, yeah, I need that.
Wait, don't you mad?
nothing else. Good. But you guys do print? I've never even a bit. Let's say. Otherwise, it much more. It looks too low on the side of it. But as long as I get it, as long as I can get it a bit, you're probably. So on this.
You wanna move the thing? Can we move it like, oh no, we can't.
Yeah, you gotta have the bed too low. You don't want to damage.
And then we have the.
How's that feel?
Yeah.
Yeah. It was after the bug activated.
I mean, I think you're making, yeah, you're right, okay, now it's, okay, there's, now you can go down a little bit.
Now.
Yeah, go down. Keep going down. Okay, that's good. Oh, yeah, go down. Yeah, that's good, that's good.
No, last.
I don't know that. It's okay, bro. These calibration for me. You said this is the $100. Would you buy it? See. For free. Oh, but. Apparently, everyone takes these in the first place. So that's what I.
Let me see, right?
All of that.
A lot of them. A lot of like great applications. Yeah. You're talking this one. I would want them switches. But I had 5 of these. I gave them up. They threw everything away. Well, I don't know. I'm not yeah. Yeah, if you look at
Paper planes bag.
the
Oh, there we go, okay. Oh, no, I think like, yeah, it's for like, no, yeah, I want to better.
no,
Yeah, so.
Yeah. Yeah. Everything else.
Yeah. No, I'm still trying.
But I feel like no one really learned how to talk.
That's like,
Maybe you didn't follow it.
okay, it's like loose here. And then
No, it's like,
Yes, why?
like, yeah.
So it's like one of
Find
these.
the- I said to them, yeah, this might be that.
Wait, hold on. Oh, yeah.
No, it's good, everything, kind of like-
Oh, it's okay. It's this one. Cause it's like tighter as I go this way. Oh, it's this. Yeah, it's this one. On this side. Okay. Maybe you could like that.
That's like some sort of-
A little bit.
No, I like that one.
Yeah.
I like the short because that one hands off.
Is it? Okay.
Very nice on our party.
I think, like, between. Okay, first, whoever gets the printer calculator first, really hard to grab it. Whoever gets the calculator first, and I'll take it to make sure it's good, and then we'll.
What should we do?
Is it a fake place?
Oh, what now?
What?
I don't have that one.
Oh,
Ah,
that's
what?
like really
This is fun.
What's the edge of college?
No.
I think these two sides are good.
Tuition.
I see, it's like this. Like this here.
Or, but I'm my favorite.
It's like white and then loose. So it's this one.
I really, for myself, back in my high school. I mean, first year is called company group. And then it's like they sponsored us because our fellows was also different fun.
Okay, I don't know. Maybe center is like.
So the that out there. And then it went to.
Is it better?
So like my shirt right here, I made like. Hyperloop version for my.
There's something wrong.
Yeah, I have it. Very good. Yeah. We designed it in-house. Anyway. Yeah. So, I don't know, I am back there to keep other middle schoolers, high schoolers. I taught mostly middle schoolers, some of them Montebello. Last semester. We're turning on. And some Arduino as well. Even though I want to get more.
Out.
My neighbor's teacher. I'm big every. No, it's not. I did not. We're gonna increase the speed right now, just to see how fast we make it.
Yes.
Yeah, you know, speed.
Yes.
I thought you doing that.
Might as well, 300 for 250 is good enough.
What are you doing now?
Increase the speed of the video.
Did you say it was bad? Did you say it was bad?
Yeah, it's that, it's like 500%. 250 is it's not gonna go like insanely fast, but it's gonna go faster.
We can check that.
I think I just look at it.
Nah, I think it's a little.
Do you want it now?
I remember suffering.
Don't hurt yourself.
I remember suffering with camera, it's so long.
You're gonna get, it's like 30 burn your hand on that.
It's 200 degrees Celsius. You couldn't see a line. Yep. That's no going up.
Honestly, I mean, I can put top on there, so it's pretty nice. Again, let me stop it like, so it's not like.
Why did you not like that?
You know, sometimes when we're looking at very decent. And then you eat it like, why is it pasta? Okay, okay. We're spending a lot of time on learning, calibrate, educate. We're gonna do, but are you gonna keep? Are we gonna keep?
I don't know, what do you think?
Whatever, once we.
No, yeah. Everything is, yeah.
On my, it's really my goal to go.
How was yours? Oh, me too. Yeah, I didn't do a lot of like, I was just like chilling out there.
We got three.
I like class included music.
Go down.
We just had like a this, but it wasn't like. Wait,
I'm
do
not
you have any class?
And now you're about.
No, not this semester. Take that next.
Actually,
Not this semester. I don't have Friday classes this semester. Oh, okay, that's good, yeah, that's good, no, I have classes. Cause I have some people doing the gap,
I don't know.
so like during,
I don't think I got it.
like some of my friends.
The party
They're
team,
like, okay. Did you just have like a bunch of projects to do? Yeah, I have like my midterm on Tuesday, so yeah, right now, like, we're just like showing, we're talking about like what we're gonna do some days, so. Yeah, I just booked like our kitchen for sure, and we're all like, yeah, everything was due this week, we were in hell. That's crazy. I know, like, all my, like, it's just my class that, like, isn't doing anything right now, because we finished, like.
So these
but
ones
all
I
the
get
other
on.
ones, yeah. So have you ever had the 3D print before for like doing a model? Yes, yeah, I have a 3D printer after, but I have like the automatic, or like, I don't know if to do all that, it just like levels itself. Nice. Yeah, but I broke the automatic level, so now I have to like do it by hand, yeah.
Yeah, learn the basic manual way, the good way. It's
I
really not
didn't pay like $200 to do it manually.
I think probably it's great. Probably it's good.
Yeah. Or have you used it? It's not like it'll be summer, but I'm not, it was like. Long started in the middle of moving and like, once you get outside, I moved because I knew I could do it. And then I was like trying to set up like tables and stuff.
Yeah, but that is not okay.
And also really using for it. Box and like, it sounds like this morning, information to like coming to know how to do it. Okay, yeah, mine is still. I see. Oh, so I have not actually printed anything with it yet, but I did assemble it this morning. Are you excited? Oh my god, yeah, I was like really excited. I'm still cool, like for when I was like first doing it, like I couldn't like not watch it. I was like watching, it was like a 2 hour like process to like do something like a little late. I was just like, watch this all day. Yeah, like it's so cute, like it's just doing it.
My screen's coming off again.
You have the automatic level or the. I think it has both. So, like, it has, I'm pretty sure when I was buying it, like, I could do it manually, get something broke. Oh, yeah. But I think it has something on that. Okay. Automatic level is gonna stay. If you have like a project due the next day, we auto. But now, like, since like the level, have to use like that's the same size as the just like that's just the top of mine. So I just put like a piece of cardboard. Yeah, it's not small. That's all I can do.
Yeah.
So what's usually get to? I think it's like a NASA, so we're like, we're participating in like a competition for NASA. And we're like working with, AI and, yeah, so it's like technology based. There's like the other topics that are doing like.
I'd say most of your print happens.
Is this your like topic two? Yeah.
Are they good?
Yeah.
No.
So, for my project, it was like shooting for the.
Alright, what's wrong? What's wrong with you? Okay, where do I go? You guys, are having a tour.
With like.
It's just time.
All you do is. We're also part of the same.
Like basically design.
What's that happening in the bed? Or going up?
I know that's really like.
So it's a two-time center. So more equity here, until that center is good, and that's kind of like everything.
That's awesome. That's nice. But like, it was not in the NASA part, I was so excited. There's this building, like a roof. For NASA, it's like, you know, where this table. That could be and for example, if you want to set the over there, like, it's gonna like
So.
So, yeah, is there like, is there a task before the controller, or if you have like, so like, how we go? Maybe it's a controller. Yeah, either like, or if you think, so, if we are, you're gonna see like the room, right? And then you tell me, how we have to put this stuff in, and then that's for the. No, okay, so whatever this, like, if they see, like monitor here, they could be like, okay, the monitor is and then like, it moves, so, I think we're intelligent. I'm in. Moving around, so, like, I'm. I have to like see what to do, how do you exploit like yeah. Yeah, I'm just like, I just got the roles, I have to do like research and like.
Take a look.
How to.
Just
That's virtual. Like other people are the like the design of the shape, like that doing after everything, right?
Yeah. Run on the recording
So
there.
actually build this.
So,
on,
I think it's
smaller scale version.
What's the outro music?
Like,
Do you want me to play music right now?
Yeah, so we have.
Dare to play music?
I think like small scale.
Some
right?
lo-fi?
Like, gonna take up the whole, like, maybe like materials. So somebody's like in charge of, people are in charge of like.
You get it?
Okay,
that's it. All right, let's go.
Okay, the idea is have it on the move. Yeah, yeah. Far-fetched, but wait. So the graphic is gonna go crazy, that's gonna be like, yeah, that's why you need like people like doing research on that. So you need to have like magnetic dust at like the door. Okay, so if you're building this in your room.
You're also way too.
Oh, really?
That's good for principal.
There's been the first one. It's almost there.
A lot better than
I
They're funding
don't know.
and then it's like.
I spent over 1 hour just trying to calibrate it, this child.
They're gonna do
I think we'll make it a little bit.
That is super cool. So that's how we're gonna. This video go all year. No, that's the next year. But that's a lot of work. Yeah, it's. Yeah, we're gonna try to get it done. It's also like the previous. Having that is done and they want. That is simultaneously insane and amazing. Yeah. So it's like gonna be a lot of work. Okay, so crazy question. When you finish it, can you like yes? Yeah, I really want to see it. I would like to.
Raise
Like after they built it, the apartment like.
Wait, so
now
that's
we're
what
gonna
I'm
fall down. You don't do that, like, we're done.
Wait,
Or do you want to have her now and see what happens?
Sure.
Okay.
That is.
This will break something.
Okay. I'll do it.
I love like here.
Yeah.
Oh.
So, for the best here, I'll just know it better. Okay, time to put it on everything. For full time, not. Throw it over there. And then- Camera storage. Wait. There we go. Okay, we're gonna go here.
They were last, we were there, but.
I don't wanna print Benchy though, Benchy's too long.
When I was downstairs,
We're gonna print.
the only person I recognized was Chad, everyone else didn't know.
Oh, let me check it out. Alright. You're gonna have
But yeah, they're guaranteed to get it.
Alright.
Wait, Harris, you got 915? Yeah. Is it, let me know if it's okay.
Alright, we'll put it at 65. We're gonna match the temperature with my binder so that it'll get really fast. Oh, we'll get rid of it.
Oh, cool. Covers the bottom. It's like. That's like outside. No, it's a class, it's actually 3 classes, but it goes for a full year.
Alright, top bottom.
If you ever join the project, you can go.
Into.
One of the professors will be your advisor, but
80%.
sometimes,
Damn, Yash.
like sometimes like the project, like if you're in like a project, to be done for the project. Sometimes the professors are I start or even in a project you can join, but a lot of people will just like want to be there. And just find something to advise it. Oh, yeah, yeah, and the professor or like the student.
What is something, please?
I mean, I've never.
Maybe
seen
you're-
a report on it. I know it's wrong.
No, 90
I don't
gigabytes.
part of it, and it's after you.
Alright, there we go.
But
Hold
I
on.
don't say ever.
I'm not gonna get small though. I'll put it small.
Oh, I think you can have more.
Oh, alright. Wait, no, that's done.
Alright.
Alright, we're gonna scale it down like.
That's all good.
Oh, there we go. Trying to be. I'm not gonna read it.
Leave it up to you.
It's not gonna be. Alright,
How
that
is
looks
it?
good.
That makes.
That looks good. Yeah.
Not ours.
So you see all of those details that are on the right now? On the first code? They're not gonna show up, okay?
So I start.
So you see all this right here? Do the preview.
That's the last report.
I don't think we need support.
Are you gonna join them?
Alright, something to note about supports. Alright, let's first look at small, okay?
So fancy is cool, but it's not what I want to do.
So you see how the arm right there
Yeah.
is in the middle of nowhere? When it prints, it's gonna be like thin air basically. So you need support for that, right? And then the overhang right here is very steep. Usually for PLA, 45-degree angles, anything less than that needs support. For Orbium, it's like 55.
Oh, really? So, what do you know?
Alright, so
I don't.
okay, 17 minutes,
Short.
and this is P support.
That's a lot.
Alright, let's see how happens.
You can wipe this.
I don't know if I have a design, but also on there.
I hope that you guys calibrate properly,
They have like all the.
that it will run.
We actually need a white papers.
Yeah.
Yeah,
Alright, try to get it.
yeah,
You want to move this?
no,
So you can help me drive the print? It's down.
Like,
No?
professors have their videos.
print, you use the card, and then
Who is that?
there we
Alright.
go, medium. Alright, good luck. Alright. We have to calibrate one first, okay?
Yeah.
Good luck, guys.
Yeah.
Alright, here we go, get ready, get ready.
Kind of already.
Come on. Alright, one on each corner, come on. Look at first line first. Alright. Alright, okay, there, okay, alright, now. I think it's way too,
Yeah. Like the car, like how they're using them.
I think it's, yeah, lower,
Whatever.
go by small, watch the print, I think what's happening is the biggest color.
But yeah.
of the day.
Yeah, I was together. Yeah, yeah. Like all
Where did that go?
students like have to use that, like then they don't understand it.
You can't, all English is all better than big. You want to see a nice logic layer. Here, if it comes right here, very important, nice and everything nice and good.
Yeah.
Oh, no, it's not. So, Lower the net by.
Not excited about. I don't know if like back in.
Baby Yoda.
Oh, I want.
Like very easy.
So either I'm gonna.
That is a completely experiment. Okay.
I mean,
I'm not making too many a lot. Never use it. Never use it. Highly recommend do not use it. Throw it away for it. Once they're ready, I think we'll see a better product on their opinion. But it's okay. It's good for it to like. It wasn't all. Yeah. No, no. Now it's on fourth, third. Can't do much about it. As long as the solid is good, we'll see how it turns out. Okay.
hearing it. But what I, she was,
I don't think they care enough.
because she was
They'll get rid of it.
like, it's possible, like, that was the cool, like, the architect dominant here, but,
I don't want to use it myself.
and she was like, the.
Okay.
skirt was over there, but it's tighter. Okay, that's pretty cool. Yeah, that might, like, I might have to consider that. Yeah, but she's like, Revit expert. So. I'm gonna go back to the. Or like back down with that meter. But I discovered it like. Look at that. Dog. No. Yeah, it's something that a lot of work for fun. So like, that's not my favorite. Oh, yeah, you're good. Yeah. And I also discovered like exact dogs. So I need to try to like up it to. I don't think it's like.
Oh, completely different. Right.
Lazy.
Alright, Steve.
Oh, wow. Thank you, buddy.
Alright, Capra Capybara, how about that?
Capybara. Yeah, should I go get wire clippers?
That would be nice.
I'll take $5 fee.
The capybara.
That is there.
Chad? Alright, okay.
Nice. This is the 30 thing, right?
But I understand like the less. Oh, well, that was that. Oh, that was that one. Oh, here's it. So there was one day I read it broke down.
It's something. The rock. Alright. I want to see some nice amalgamation. Okay? So those middle school wanted me to see. Where is my phone?
Oh my god.
First of all, there's a rock necklace.
Oh my god.
Right? And then it gets better. There was a rock necklace with rock heads. Why? And then they also had. I see. I made one of the middle schoolers had my phone. So
You are.
can he pay me for it afterwards? Oh, this another beam from right. That's not. Does anyone want to talk? Oh. I want to. He was very interesting. Stuff I did like me.
They were obsessed with the rock.
No, literally, it was very interesting. And then over COVID, I had a 3D modeling workshop where I 3D model. I tried to model Willy Blanco. But this is Willy Blanco, guys. Some laughing stuff. That is yeah. Where is the there it is. Counter. Hold on top. It's pretty. Because on a inside of that, it's pretty. I'll turn on my printer here. I'm gonna stop with Benchy.
Learn about it. You didn't learn about it modern. Okay, well, whichever one it was. It's important. We go into the fire building. So we look at that. There we have to the company for that. So our this is consulting on it. What else? On the diversion program.
Is he? Bottom part of the boat. You can float. I'll press the counter scroll on my.
So they exist, but they're not really like on this scale. This might be the first one that was like on a scale, but like having a system in place. Usually it's like you want to keep them on part of the like. Oh wait, so you have like 9
Yeah.
So that's how it is. Like part of one that like.
What do you think is winning Ben?
My points.
That would give you.
My points.
I was gonna go, but I have too much.
No, I got the permit for you, like, oh, as long as.
Baby, stop this.
I'm gonna stop.
You're right.
I want to.
That's so
I'm
cool.
gonna stop.
I've never.
Ah.
You always say-
We Dr. Hughes here, right?
I don't know.
Oh.
Because the last guy in the room, he's trying to leave soon.
Okay.
Here.
Yeah, that's what I'm thinking of seeing it right now. That I was on the basic doing the money policy.
Right, so well, it's still, it just takes down to our waste that part of all of it, waste is, oh, yeah, and then they can stack up with like outside of the garden.
So.
Every building do that. It's like now there's like big nights like around it's going like all these facilities. People just doing but it's really, you know, it's now I can like tell my peers like it's in school, that would have been in school last year. It's like the apartment complex. And then for that, we have to do like because they were like really each yeah. And then we have to like get all of the toilets to like come down to one place and then like go to like the city. That's it. I can just like get it and like, store it in the basement.
All right.
So I don't need like all those excess pipes. It's okay.
Also,
It's okay, like I have the vision if I do that, I'm not like explaining it. I mean, I don't.
how long it was for you?
It's still what it's all. Yeah.
Alright, I'm gonna print the top here. Yeah.
Sorry. That's why I.
What is that talking?
Do we get to each do it?
Yeah.
Like we get our own
Yeah.
kits?
Yeah.
Get a kit?
Yeah, I'm gonna keep it. It's like where to go. Where to go?
Yeah.
Where to go?
Huh? What are you
There should have two. So third one's here. Our first soldering workshop was this one.
That's not so.
What is it? Inside of
So like my phones are all soldered underneath.
this one, but this one is actually inside of it. You power the arguments again.
Wait, yeah, could you just make a gaming? The gaming keyboard with
I
that.
mean, you could play games with this. I do have the game for it. Yeah, so there's that. And then soldering. Here you print, you get it, here you print. Oh, look, it's printing.
It sounds nice.
Like this, right? That would be the plus, right? The plus, right?
Oh, yeah.
No, plus is, it's like a kind of butterfly with rents in your population.
It's like it's all lead based, so it's all good.
Yeah, that's why I want to do stuff. Next semester. I think it's started.
Yeah.
No.
Why? No. Look at the lovely pose.
Or like. It's actually. You're not really like. But you don't. Like I'm like.
I think it's gonna start.
Okay, well, so I have to get like, and it's like, that is not working well. That
A lot of them keep on buying.
you're working with like solder, you're working with solder, and you're like really soldering, you're making workers.
Like,
Which I would do if you're just like working with solder, because they actually like working with like solder, and then you can if that is the case, just like you work with solder, like that's how it was. And I think like it would be really hard to work with solder. It's like a thing. How long it takes to do it. No, it's oh, sorry. Oh, yeah. So, yeah, it's just a little bit harder to work with. So, that's why you have to.
Yeah.
It's not like, when I just do the, I like them. Was it something or
This would be,
I don't know how that works. Like the tax can undo. Yeah.
not saying this.
you have a production range.
Workshop, but.
Just do it sideways.
Yeah.
Usually.
We don't do that.
For this.
For those of you who handle out. I get to.
I think there are some kind of relief, like I think we did before we did.
Yeah, but after that. And then you can add these comments and things. Like I guess with. So. Yeah. Oh, 1 kilogram, yeah. So this rule is like less than a kilogram. So it's way even cheaper.
what is it made out of?
So chili is basically, you think of it like corn, squish, compressed, plastic. Because plastic is just oil, right? So that's what it is. But it's really a chemical compound. They call it polyurethane, some kind of acid. Chili is like acid. But if you look online, it's like,
Oh my god.
it's not an acid.
She's always smart.
Anyone else?
So she was up to.
5.4 million.
They are.
Okay, so let's say I.
Okay. So like.
All right, so I'm a I can search.
So much pressure on you.
Like-
Oh, I can tell my time.
I feel like.
Those are like
Anyway.
so hard.
So Hatchbox, that's a good brand. You know, for most filaments, this is $25 per kilogram. So this right here is about a kilogram of filament.
Hmm.
On the camera. But yeah, that is 1 kilogram of filament right here. So
You said
it'll-
this one was bad though, right?
Amazon Basics, don't go.
Basic.
Do not use Amazon Basics. But for most Hatchbox is good. There's also Overture. So if you look at what is it again? Overture. That's also a good brand. Again, so it's a lot cheaper. So it just depends. PLA Plus is like PLA but stronger. There are certain more properties that PLA Plus has over PLA. You might want PLA Plus instead of PLA. That's higher melting temperature as well, I believe. Yeah, there's like a lot of stuff out there. The Eason that you're using is pretty okay. Honestly, in my opinion, Hatchbox is pretty good. The stuff for this right here is all Hatchbox. Filament. This Amazon Basics. This is also Hatchbox. The filament. This is my own Marbium. It's a lot like you see it's a lot more shinier. PLA is usually shinier than like other filaments. But a lot more muter or matte. Just depends. There's like a lot of stuff like if you go into this like I want to say metal like
So this would be like, this would be a stronger material.
so it's infused metal with like flakes in it. That makes it shinier, makes it a lot more stronger than PLA by itself. But it's like stuff like that. There's wood based ones, carbon fiber based ones, I think. There's like a lot of stuff out there. You can print with. It just depends on your printer. Can your printer handle the temperature that's required?
Could this one have
Let's see. Let's look at its printing temperatures. This one here.
Yes, maybe.
I hope it's able to count. 230. So yeah, definitely can. Because I can hit 245 on mine. And some printers I can hit 250, 260, 300. It's on sale, 150. 300 is like it's a long time ago. $60. It's pretty good for like 150 to 300 or so.
That's crazy. I thought this would be on.
Nah, this is seeming cheap, bro.
This is cheap.
This is have you seen okay, let me check. Okay. One of the cool like if you want something that will just open up place, you know, it has AI built into it. It can go print really fast and really precise stuff. And you don't have to worry about any print shifts or anything like that. It can handle everything for you. So you get the for me. 5. Okay. This thing, pretty hefty price. Okay, the build plate is about similar to these ones over there, but it has a camera on it. It has AI camera like with AI, so like if it detects a print shift, it'll correct for it. If there's like some kind of issue, it'll tell you. So it's like people are reviewing on this all the time. It's really fast. Like 500 millimeters per second. It's really fast. This is going at 40 right now. 40 millimeters per second. That can hit like a lot faster. You can hit like I think you can print my car. It's like 4 hours or so, 4 days. You'll probably in 2 days or something. It is insane, but it can't fit my car because this build plate goes all the way there. That one's like 8 by 8, I think. This is like 12 by 12. Huh? Then you print it. I can't. I'm not gonna print it. I'm gonna go home.
You stop at your room first, right?
No, I'm not gonna. I can't. No, this is my printer. This is my home printer.
So you just what about those two?
They'll either go in my car or they'll go. Okay, if they're in their room, I'll take it. But
Yeah, it's going to ruin.
yeah.
Because I could break it potentially.
All right. If we go go to the room, then we'll see. Okay. But yeah. There's like a lot of like the Bamboo X1 I think is also one important printer out there. Also really expensive by the way. So, and not bad. There we go. Oh, that's a Calibration. That's a Calibration. Where's Bamboo?
Oh, okay. And you both equal.
A lot of things. Flashboard is also a good brand you can also get on a Flashboard.
Yeah.
Did I hear the resin printer? So you see it has like the top plate, and then you see all the fill, like all the stuff that's underneath it. It's the pool of resin, but cures and stuff. Cures and stuff. Yeah. It's like a radiant filament as well.
I want that.
Yeah, but it's no, not buying anything for you. But yeah, yeah, a lot of stuff out there. Mhm. Yeah.
It would pretty much.
A top. I think I was my face.
Mondays until 4, Wednesdays till 2. Monday, Friday. Morning.
What's that?
Yeah. Right. But and I usually around and I said so like I really I was in the homework and I yeah, exactly. Right. I'm still yeah, I got eating every other Friday from 11 to 1. Friday, we have 27, right? Yes.
Oh, yeah. This late? Yeah. I can't really get this just kind of but
You're not. And that was my fault.
So that mental line over there, I work really strong. And alternating black and white.
I really design. I think we're all
Hey, what's the third delay?
Why is it?
The last code.
Oh, oh.
Did I
do it?
The boat?
Oh, yeah. Okay.
I thought they happened. Because it takes 4 hours to print. I'm not gonna wait 4 hours for it to print. Just leave it here overnight. No, it's my printer. I go home with it. Just leave it. I better. Alright, I think enough time at school as it is. It's safe here. No, it's not. Everything. My house.
That's because it was safe, right?
What you do? How are you?
Yeah.
I'm gonna keep it up.
And you charge people.
I get money back. Hey.
You get money for your.
For mine, I don't.
I didn't say that.
Right. Right here. Yeah. Yeah. Part of it.
Okay.
Yeah.
Well, why isn't it not?
Why would it?
It's because it's like plastic. Like as in like, when like the hot.
When the hot end does touch it, it will melt. But because it's in for a week, and also the wind break out.
But the heated bed doesn't have it to melt? Or at least off gas?
No. The reason for all of this that you see right here is because of like the air in the car being stuck on it for so long, I took it off this. But here's the point.
Now it's gonna be sticky, right? Because it's big. No, it's sticky, it is, yeah, so like top one gonna be the most sticky.
I way that I the whole practice with this game or the way I do it. Like you guys, it's never seen. And in case it is, I use all
What's fan doing part of the?
I is a carbon the 3D pan is really expensive and really good. And people are like reading over it.
What's fan do part?
That's the brand.
The what?
That's the brand.
Oh, the band?
The brand. Yeah. Alright, I'll find the actual thing.
There's not.
Bamboo Labs.
It is.
Oh, yeah, that's
Cool.
That's the bamboo with the U. That's the bamboo X1.
So you get like 3 different colors?
Four.
Multicolor?
Has a LiDAR on it too. It is
Yeah.
expensive.
You wanna buy it?
I'm not buying it. It's so no, it looks super expensive. Let's see.
It's $200. Oh, never mind. It's actually cheap.
Hey,
That's
700.
Hey, that's not bad.
No. I think no. The one that we're talking about is the one $2,000.
Oh. You wanna buy that?
I modeled that and then I printed it out. So my model here. The model is on. Yeah. And it's multiple parts too. You can take it off and you can like. Let's see. This one's not really. This one's, yeah, you can take out the parts. So the way I printed it was this. I printed this like this, and this one like this. All these legs separate, all the parts separate. This part here also is I inserted into it.
Wow.
So then I'm just gonna pop it together. I should do it the other way. This is the top.
Top what?
Top just to spin around. Play it.
Oh.
It's on. Here, there it is. So I'm gonna print it upside down, and then when you support, I spin it. So you can keep it. Who wants to- So that's support material. So all this overhangs, it's not gonna come out of nowhere. Can't print out on nothing. So
Where's the
material.
It's gravity system.
Yeah. Also, it's very thin.
So you break it off.
Yeah. Really great. Or just your hands, depending.
Yeah.
But
I like my
has tree support. It's almost done, I think.
That's almost done.
I think so. But it says how much percent is this? Not almost done. Like, on my. But it should be done about like in half an hour, so it'll be done.
Why you guys stay here until it's done?
Well, the workshop lasts till 8 o'clock, so yes, I'll be here till 8 o'clock. But you know, has questions, comments, concerns, hit me up.
You wanna go at 9:15?
No, that's after the workshop's over.
Sorry, just it's late.
Yeah. 5 to 8. That's the designated time. But yeah. Let me see if I can open up the polar bear. That's not what I want to do. I think it's in a project.
We should try cleaning it myself.
Yeah. Even. Yeah.
Yeah, you just leave us kind of do.
Yeah.
They said we hopefully go with about because our foreign candidates, you know, that's how they turn out for this.
It also supports the original. You've got support software. You can able to. Oh.
So, I like
There's software, supports here, supports all over here, all over here. It's support everything. Yeah. I don't think they ever used something small.
Huh?
I don't think it supports for either.
Because the arm.
Over the years.
Oh, they didn't support. It's not bad. All right, it's time. Pick. We can do with this one. Get out.
You just better do
So, let's see how amazing this log is. It doesn't look very good, but it's also because it's tiny. So you see, the smaller you go, the less risk you have. So, hopefully here the cards are actually optimized for you. I don't think it's gonna work.
It's so realistic, right? I guess this is real world, it's real, it's a great example.
I think that.
But yeah, so this is like, take a lot, but it's really.
You also know what this is important.
Like these are own brain curves, yes.
Oh, for once to have.
Yeah.
Oh, like three.
I have no idea.
Oh, yeah.
Oh.
So it was called, I already had my laser feedback. Okay.
Looks like he's.
And you just use it, but higher.
Well,
It becomes like.
You love the support.
This is so boring.
For the question.
yeah,
Is that we were.
Huh?
able to-
You don't know.
Yeah. That they were talking about the master buildings, you know, like, hey, you must say the structural health of the vendors. Directly on the south. Like, you later on. Right. We only tried. I found it from an article. Okay, I'll send it to you. It's so pretty. I'll like give you all these applications. Right. Yeah.
Okay. So there's the models for yes. Oops. The derpy bear. Well, you can move the head around. But
We need to find. So.
yeah.
Like,
Alright, hold on. Yeah. Oh, very cool.
This is like what I do. I love it. So that's my favorite person. My best friend is like very similar to you.
That one over there is the
More into like, like she's like more into like that stuff. Like she was like having all of these like medical because you're like how to do this, what to do that.
oh, these are pieces.
Next week is alright.
Some of them are really hard to find.
Okay.
This one here.
So you guys, yeah, that's you guys.
Yeah, all these are, it's also separate segments that I together.
We did them all into one.
Yeah, it's one thing,
Yeah.
all together.
My sister, I. Or not open. My sister.
Yeah.
Yeah, she graduated last.
All of
This,
that. Is that what you're doing?
Yeah. Working, it's called.
You can do it that way.
Los Angeles. I do have. Okay, yeah. Yeah, of course. And like, they hired like they sent like pretty quick. So like I like to post you. I really think so. See you later. Okay. Okay. My review, that's my I'm like really bad at. Okay.
So the one our friend was to show. that you could make that. So you show more.
Very hard work, yes. I mean, we have time for another one. Another Yoda? Oh, not Yoda, but anything else. If you guys want to calibrate this. You do better this time. But it's quite tough. Oh, Yoda. It was Yoda.
Oh, they collapsed.
Yeah, it's expensive, yeah.
Probably else, something simpler to start to print. I see. Something simpler for the print.
Don't really things for they're not quality. Don't just. Yeah, the one. Say, I'm ready to what is for the.
But physics actually.
Gosh,
Yeah.
is the premium room ability under 5 plus or under 5? Between.
Oh,
Under
your first
five. And if I-
It's like, thank you.
Oh.
Whatever reason.
Yeah.
It's
We
just thought a lot. Doesn't continue.
So this one right here. So this one right here, what happens if you lose power? Okay. It should be able to cover,
Alright, okay. Yeah, that's what I want to cover. Maybe against.
but it's okay because the top cover. What does it say?
Mike?
Yeah. It's in print. I don't resume the print, but it failed. But click on here, you can recover after it's get power. You see, I should have put a brim on this one. Oh, it's good. But yeah, if I put a brim on this and it wouldn't have fallen like this. There's no
What?
Sometimes.
I tried.
That's unfortunate. That's not a good.
Yes, it's like right under. Oh, okay. I just do that to show you. Yeah, it's over there. Yeah. Recording.
Let me test it.
Guerrero, yeah. Are you from Mexico? No, we're starting.
One more through.
But it's nice to go there, but yeah, I do. But I have my 15 on my daughter, with my son. Yeah.
Yeah, let's see how it
It's
is.
nice. Very pretty. Is it?
Actually, work done.
Thank you for coming.
Table temper. Yeah.
So this one failed here because I didn't put a brim on the actual piece down here. So a brim would have expanded this bottom layer, causing a bigger hat basically. So since I didn't put that, it got stuck to the nozzle and it came off. So it's part of the top now. But it came off.
So where's the, is this a support?
Yeah, so you need to kind of pick it off.
So you used to teach this
Middle school.
middle school?
Yeah. Like,
As a job or?
yeah, the job. I was like, so over like, this past semester, this company that used to sponsor us for my high school, they asked me if I could teach 3D printing because they didn't have the 3D printer mentor. I'm like, okay, I'll just like teach them 3D modeling, some 3D printing, some splicing, and some Arduino as well. So I know some electrical as well. So I'm trying to like introduce them to STEM. Like I really want them to like learn some STEM. I think I got one person into getting their own 3D printer. So I'm like, so but yeah.
And this is where?
Is that Montebello? La Merced
Yeah, yeah.
Intermediate. That's yeah.
Yeah, I'll go out there.
So who pays you?
The company did. So the schools pay the company as a contract kind of thing, and then they pay us our
The company pays you.
Spider 3D. Spider 3D lab or Spider Labs. They call it.
So you get some doing? No more?
Not more. I want to do more aerospace. I want to do some aerospace internships and everything. But I do plan, like I do kind of want to like still teach students like some STEM, introduce STEM kind of stuff, like as like a side kind of thing. But yeah, I want some more aerospace internships and more excited to get in that area. So yeah, it was really cool though when I did get to do it. So it's like really nice.
Everything.
Yeah.
Everything's done.
It's really exciting. Like once you learn a little bit of everything, like in my opinion, like you know to like build your own like your own decorations like this for my like a bunch of stuff. Like I built myself like a headphone hanger for my table because I made a headphone headphones, but so I kind of like measured out my tables like the way it's like the shape of the edge on the top and it's like made something and it clips on and it's been like working for it since like for like 5-6 years now. It's been like, stuck on my table. Always like I've also like built this
Inspired by like not like yeah, in our side.
How did you print this out?
so I printed it. See the shiny side right here?
Oh, so this is setting up.
And then I glued the pro afterwards after putting it. So it's some hot glue in there. Huh? Why? So this is based on a book that I read. It's called Kiss of Crows. So in it, this is like the main character. His name is Dirty. And his nickname is called Dirty Hands. And so I'm like Dirty Paws. So
Popular building. I guess this is the support.
yeah, support and
This on this.
so this is the main stem at the top and this is support.
Oh, this is the spine. This is the stem.
Yeah, so you would use it to like you can use water.
Yeah, with us.
Yeah. I've also built this.
Yeah.
Right here. So this snap right here. My 3D printer is on this right here. It's not the 3D model there. So based off of this design stuff, where I 3D modeled it, and I 3D printer out. Put some like wiring, circuitry.
Wow.
It's pretty cool. And I kind of like rating on it. I'll program. So 3D printing and circuitry together. So it's really cool. Yeah, boggle there.
You want the calculator as well? You want to see this calculator as well?
Yeah. So then
Hi, Dom. I have 2 German Shepherds. One's a Husky mix, one's a pure German Shepherd.
So yeah, I